Hello everyone, my name is Madhu. I completed my internship from Emertxe Technologies, which is situated in Bangalore, and it is a virtual internship. And during this internship, I completed a project called IoT based home automation, and my project guide is J Lakshmi ma'am. So, so today I will be sharing the knowledge and skills I have gained during this internship, and these are the contents that I have learned and executed during the internship, such as C and C++ languages, introduction of IoT, introduction of embedded systems, project requirements, etc. And we write the program in the Arduino IDE, and through PiximLab we've developed the project, and we can see the working of each peripheral which we going to use in this project. First of all, I will explain the project. Later, I will explain each peripheral used in the project use what I have learned. Introduction of project, purpose and scope, home automation, integrates smart devices and systems to control garden lights, temperature system. Here temperature system we used heater and cooler, and water tank remotely or automatically, enhancing convenience, energy efficiency and safety. Tools and implementation. It typically uses platforms like Proteus with microcontroller emulators like Arduino IDE with virtual serial monitors, enabling testing, learning, and prototyping of automation logic in a safe, cost effective way. And these are the topics that I have learned in this internship. Data types such as integers, floats, characters, unsigned integers, etc., and conditional statements such as if, else if, and switch. And also we covered loops such as for loop, while loop, and do while loop. And next, operators like arithmetic operators, assignment operators, logical operators, and bitwise operators. And next, arrays. Arrays is collection of same data types elements, and pointers which stores the memory address of another variable. And comes to functions, and functions are two types. One is library function, and the second one is user defined functions. And comes to storage classes are auto, extern, static, and registers. And various macros and header files such as hash include studio.h, hash include string.h, etc. And comes to C++, the first we were thought was the difference between C and C++. So the major difference between C and C++ is where C uses procedure oriented programming and C++ uses object oriented programming. Concepts of OOPS includes classes, objects of classes, ac- access modifiers, that is private, public constructors, and destructors. And it consists of four things called as pillars of OOPS in C++, and they are encapsulation, inheritance, polymorphism, and abstraction. Introduction of IoT, definition and purpose. IoT refers to a network of physical devices embedded with sensors, software, and connectivity that enables them to collect and exchange data, making everyday objects smarter and more interactive, such as controlling the lights and fans of a home remotely or automatically. Applications and impact. It powers innovations in smart homes, healthcare, agriculture. For agriculture purpose uses sensors like humidity sensors, temperature sensors, and soil moisture sensors, and industry purpose sensors like fire detection sensors, etc. By enabling remote monitoring, automation, and data driven decision making for improved efficiency and convenience. Introduction of embedded systems, definition and role. Embedded systems are specialized computing systems designed to perform dedicated tasks within a larger devices, combining hardware, microcontrollers or processors, and software to control functions like sensing, processing, and actuation. Applications and examples. They are widely used in everyday technologies such as washing machines, smart TVs, medical devices, and automotive systems, offering reliability, efficiency, and real-time performance for specific operations. And further, the embedded systems are classified into four types. First one is real-time, second one standalone, third one networked, and fourth one is mobile types. Comes to first one, standalone, follows instructions blindly, takes decisions on its own without human interactions. Examples: self-driving cars. And comes to real time, means completes tasks within a given deadlines, and it is further divided into hard real time and soft real time. And comes to third one, network, means help in getting connected. Example, routers. And the last one is mobile embedded systems. These are small and portable systems that often uses wireless communication. Example, smartphones. And these are the project requirements which we used during the project, such as LED, CLCD, temperature system, LDR, serial tank, Ethernet shield, and Blink IoT app. We will learn each one of the peripheral. First one is LED, light emitting diode, simpler device used in most of the embedded applications as feedback, works just like diodes. And the Arduino Uno consists of LEDs inbuilt, and that shows the power supply of the Arduino Uno. Low energy consumption, longer life, smaller in size, faster switching makes it usable in wide application fields like home lighting, remote controls, and surveillance. Next, the second one is CLCD, character liquid crystal diode. A CLCD is a display module used to show alphanumeric characters and symbols. Common types include 16 into 2 or 20 into 4, meaning they can display 16 or 20 characters per line across 2 or 4 lines. It is used to display sensor readings, messages, or status updates, typically interfaced using parallel communication with controllers like Arduino or PIC. And next, temperature system. In this project, we used LM35 sensors. Uh, it measures temperature using sensors like LM35 and sends the data to the internet so users can monitor it remotely on their phone or computer. And the components are: the board includes a microcontroller like Arduino or ESP8266, a temperature sensor, and Wi-Fi or Bluetooth module to connect and share data with cloud platforms or mobile apps. And the LDR sensor, light dependent resistor function. An LDR sensor detects light levels. Its resistance decreases when light intensity increases and increases when it's dark. The changes helps measure brightness. Common uses: It used in automatic lighting systems, solar garden lights, and brightness controlled displays to turn devices on or off based on ambient lighting. The project demo, I will show you the LDR sensor working. And next, serial tank. Concept is a virtual serial tank simulates a water tank system using software tools and serial communication protocols like UART to mimic sensors, data, and control logic without physical hardware. And it consists of two valves. One is inlet valve, and the other one is outlet valve. Later, I will show you in the project demo. Uh, Used in IoT projects, it helps test and visualize tank level monitoring, pump control, and data transmission to cloud platforms using virtual microcontrollers like Arduino Uno, making it ideal for learning and prototyping. And Arduino IDE stands for Integrated Development Environment, where we can write our code and upload to a physical hardware using the uh, their USB cables or power supply cables, and contains a text editor for writing code, a message area, a text console, a toolbar with buttons for common functions and series of menus. It connects to the Arduino hardware to upload programs and communicate with them. In the Pixim Lab, Pixim Lab is a real-time emulator of development boards with integrated MP Lab X debugger. In this Pixim Lab emulator, we have to upload the .x file so that it can run the program according to our requirements, according to our code. We use Atmega 328P Arduino Uno board, and we upload our program in the format of .x file. And the last one is Blink IoT app, and purpose and functionality. Blink is a mobile and web-based platform that allows users to control and monitor IoT devices remotely. It supports hardware like ESP8266, ESP32, and Arduino, making it easy to build smart projects with real-time data and automation. Features and setup. Users can create custom dashboards using widgets, buttons, sliders, graphs, connect to devices via Wi-Fi or cellular, and manage them through the cloud. The app simplifies IoT development with minimal coding and quick setup. And this is the screenshot of my Blink IoT app in my mobile. And here we have one heater switch, cooler switch, temperature gauge, inlet valve switch, outlet valve switch, water level gauge. So by using these switches, you can control the peripherals of the project. I will show you the code now. And this is our Arduino Uno code, uh, and we define the Blink template ID, Blink template name, and Blink authentication token. With the help of these only we can control the things and use IoT Blink IoT app. And next we included the header files like SPI.h, Ethernet.h, Blink simple Ethernet.h, Wire.h, Liquid Crystal I2C.h, and this is the address of the Liquid Crystal. And we included the header files like LDR.h, main.h, temperature system.h, and serial tank, and we define the switches: heater switch, inlet switch, outlet switch, and cooler switch, and blink timer uh, to update the temperature on blink app at particular period. Blink right, and this is for cooler pin, cooler switch. If the cooler is on, it will show on the CLCD cooler on, else it will show cooler off. And this is for heater. If the heater is on, it will show on CLCD is heater on, else it will show heater off. Blink right, it is for water tank, inlet switch. If the switch is on, if the inlet is on, it will show inlet flow on the CLCD, else it will show off on CLCD. And this is for outlet switch. Enable outlet. If the outlet switch is on, it will print on the CLCD outflow on, else outflow off on the CLCD. And this is to update temperature readings on the temperature gauge, and this is to update volume, water volume on the gauge. So here handle temp will handle the temperature. If the temperature exceeds 35 degrees Celsius, the heater switch will automatically turn off and will print on CLCD's heater off. And next, void handle tank. Handle the tank. If the volume of water decreases less than 2000, the inlet valve automatically turn on. And next, void setup to run the program for single time, and into LDR, into temperature system, and LDR clear, LCD clear to clear the screen of the CLCD. LCD home, set cursor, it will print on home automation on the CLCD, and delay for 1 minute, and it will clear the screen of the CLCD. LCD dot clear. And here loop where the program run continuously. And we have different files for LDR.h, LDR sensor, main.h, where we define the switch pin values, and the serial tank.h, temperature system.h, where we define the switch numbers in Blink IoT app. Now I will try to show you the project demo. These are the peripherals used in this project. This is CLCD. It's already showing the temperature, water level, cooler off, inflow off, status of cooler, and status of inlet valve. And this is LDR sensor, and this LED and Ethernet shield. The temperature system consists of heater and cooler and temperature. If the sunlight increases, the LED will turn off. If the sunlight decreases, the garden lights will turn on. It works like this. I already uploaded the .x file in the Arduino Uno board. Now I will try to control with my mobile app. Just a minute. Here I am turning on the heater. Here it's the you can see here the temperature is increasing and it's showing the heater on. When the temperature exceeds above 35 degrees Celsius, the heater will turn off automatically. You can see uh, you can see here the temperature is increasing. Now you can see that the heater status is off. When it exceeds 35 degrees Celsius, it will automatically turn off. Now I will turn on the cooler switch. So you can see here the fan is running. Now I will try to turn off. Now I turn it off and I will show you the what cereal tank. Wait a minute. So I try to turn on the outlet valve first. It will the so you can see here the outlet valve is on. So the water level is decreasing. When it decreases 2000 liters, it will automatically turn on the inlet valve. So you can see here now I am turning off the inlet valve. It's automatically turning on because the water is less than 2000 liters. Now I'm turning off the outlet valve. So you can see here the increasing water level in the tank. Now I am turning off. So you can see here on the CLCD the increasing level of water flow. And I will try to turn on the outlet valve. The water will decreases. When it decreases below 2000 liters, the inlet valve will automatically turn on. As you can see here, it on automatically. Now I will turn off the outlet valve. So as you can see, it is increasing. Now I am turning off. So this is the project we done during this internship and how this is work. So I think I showed everything. And finally, thanks for the Emertxe for providing this internship and giving this wonderful opportunity.